Well, today we looked at some different situations that will give you no solution to a system of equations or infinite solution to a system of equations. So I had you think about it. Let's say you're running in a race and you're running at the same speed as someone, but they get a head start. Will you ever catch them? If you're running at the same speed and they get a head start, will you ever catch them? So I had you try it. So Ruby is running 10 kilometers an hour, and Thomas is running 10 kilometers an hour, but he gets a head start of 1 kilometer. So when you start the race at the starting line, he's already out at 1 kilometer. So I had you write an equation for Ruby and one for Thomas. If x is the number of hours you're running and y is the distance, well, Ruby is y equals 10x, and Thomas is y equals 10x plus 1, because Thomas got that 1 kilometer head start. Now later on we made it 10 because it was pretty hard to see the difference in your lines in your calculator, but you graphed your two equations and you set your window to a reasonable scale and range, and I said what word will describe your graphs, and you guys could see it. They are parallel lines, and since they were parallel, the lines will never intersect. Thomas will always be ahead. So there's no solution to the system of equations because when you graph them, they're parallel. That means there's no point of intersection. There's no ordered pair that'll make both of these true. And if you just think about it for a minute, it's easy to see. If x is 2, this is 2 times 10, and this will only be 20 for y. But if x is 2 here, I get 20 again with 10x, but I'm always going to add 1. So if we run at the same speed, Thomas is always going to be 1 kilometer ahead of Ruby because he got the same head start. And so when we graph those, we get parallel lines. So there's no ordered pair that will make x and y the same number at the same time, because 10x is always going to match this 10x, but I'm always going to add 1 to get this y. So Thomas will always be 1 bigger than Ruby. No matter what I put in for x, that will be true. So then we looked at what happens when you try to solve this as a system of equations. So if y equals 10x and y equals 10x plus 1, then 10x plus 1 has to 10x has to equal 10x plus 1. But when you go to solve this, so I set 10x up equal to 10x plus 1, and I subtract 10x from both sides, and then I get this kind of weird answer that 0 equals 1. And I said, does it make sense? Does 0 ever equal 1? Well, no, it doesn't ever equal 1. And so when this happens, there's no solution to the system, which means that these two lines are parallel, and when I solve it algebraically, I get something that's not true, and that means no solution to the system of equations. Okay, then we looked at a real-life example of two different job descriptions. We looked at the table, we looked at the graph, and the graph had parallel lines. Because job 1 paid $2,000 more a year than job 2, but every year both jobs got a $5,000 raise. So n is the number of years, and they both have the same raise every year. So whatever n is going to be the same. 2 years, it's 2 times 5,000. 3 years, it's 3 times 5,000. But because job 1 started at 2,000 more than job 2, job 1 will always have 2,000 more dollars paid per year than job 2. Okay, so when you try to solve this inequality, we end up with something like we subtract 5,000 in for both sides, and we get 28,000 is less than 38,000. And that's true. 28,000 will always be less than 30,000. And that also shows you that there's no solution to this inequality. There's no value for n that will ever make these the same. But 28,000 will always be smaller than 30,000. Okay, then we practice some of these. So let me just put the slider back down. So I told you first you simplify each side of the equation. So you can use the distributive property to get 21m plus 6. And on the left side, you can put your 18m with your 3m, which is 21m. So the next line is 21m minus 20 equals 21m plus 6. And then you subtract 21 from both sides, and you're left with this statement that negative 20 is equal to 6. And it's not true. In fact, you can see that if I put 2 in for m, this is 42, and this is 42. But from the left side, I'm going to subtract 20. And from the right side, I'm going to add 6. And there's no way these will ever be equal, because this is always going to be subtracting 20 to the same number as this side is adding 6. And that's why you get the negative 20 equals 6. So there's no solution to this equation. That's what that means. When you get something wonky like negative 20 equals 6, there's no solution. Okay, then we tried this one, and again I said simplify the right side first. So this is 80k plus 6 minus 38k, so you add the opposite, so it's 80k plus a negative 38k on the right, and then we end up with 42k on the left equals 42k plus 6 on the right. So now I'm going to subtract 42k from each side, and I get 0 equals 6. And that again tells me that there is no solution to that equation. So to sum up, what does it mean if you get a statement that makes no sense? It means the lines are parallel. It means there's no solution. Okay, and then we looked at situations where there can be infinitely many solutions. So we looked at these two equations. When you first glance at them, they don't look like they're the same. But if I want to put this in my graphics calculator, I need to get rid of the 7, so I need to add 7 to both sides. And when I do that, I get y equals 3x plus 7. So it's the same line, the same equation as the first one. So these two equations are actually the same line. And because they're the same line, there's any real number can be x, and I'll get the same number for y. So I would just see one line if I graph them. So the answer, the solution to that system of equations is any real number. And just remember, sometimes they're the same line, but they're in disguise. So once you get them all in the same form, either standard form or slope-intercept form, you can see that they're the same equation. So you have some ALEKS to finish for homework. 3 hours and 15 topics. You have a few problems to practice on pages 219 to 220. And then you have a quiz next class on the systems of equations and lesson 4.4 and 4.6. Have a great weekend.